So I am trying a few things. I've ordered some toroids or ferrites or whatever you want to call them. I found these on DigiKey's website. I ordered some, I think it's 140-43s. And the cheapest I could find those was like not $100, it was like $8 or $9 a piece on Amazon. But then I looked online and I could get these pretty cheap compared to that, and they're roughly the same size as a 140-43. Then you've got these, which are quite a bit bigger. And I've seen multiple videos on YouTube where they talk about these being way better than even the 240-43s. You can see how much bigger that is. And then I found these as well. So this is a 31 material. That's a 43 material. And that's a 31 material stacked together. So I've been fiddling with this and winding some stuff up for a while. And then I'm also trying this. So this is just a little 3D printed enclosure that I made. And essentially the idea is I've got a rotary switch here, and I've got a multi-tap transformer here. So I kind of messed up. You can see where I've bridged from here to the center pin of my connector there. Originally, you can see where it was connected in there. And for whatever reason, I'd counted 1, 2, and then connected on this wire on the back side. But then I realized that this was my first 1, 2, but then it comes up on the back side of this. So if you look here, it's like 1 wrap around, and then your second wrap around, and then as it's coming back around here, I need to tap into it, and then this is your third wrap. So it's basically tapping in between your second and third wrap. So that's what you're looking for. So that's my 2 primary turns, and then I've got multiple here. I actually messed up a little bit on this too, but I'm going to keep messing with it, so I don't see why not to use this. So I've got, I think it's 19 turns total here, and I've tapped into 19, 18, 17, 16, 15. So 19, 18, 17, 16, 15, I think 19, 18, 17, 16, 15. And 14. Well, maybe I need to look at that again. So that's 19, 18, 17, 16, 15, and 14. So maybe I did get to my 14th turn. So either way, I've got 14 to 1, or 14 turns, 14, 15, 16, 17, 18, and 19. And then the switch switches to that center pin, which goes to your antenna, which comes out to here. So I don't have a cover made for this yet. Now normally you also have a capacitor from your shield to your center pin, a 100 ohm capacitor. And the idea was I was going to have a switch here, and this was what I was going to do. So essentially I've got a 2-pole, or is it a 2-pole or double throw single pole switch. So this is a single pole double throw switch. So my switch, if it is in the off position, disconnects everything. So this would go to either the shield or the center pin, and this would go to the other. So either one of these could work. So shield, center pin. And essentially what this would do is if I switch to one position, I end up with a it would connect this pin to this connection that would then make this 100 ohm capacitor connect between the two. So I would have a 100 ohm capacitance value between the shield and the other one. And now if I switch from to there, it's going to connect my center pin through here, and this would essentially just dead end and go nowhere. And what that would do is run my capacitors in series. So I go from 100 not ohms, farad, 100 picofarads or whatever it is, to 50. So when you go in series, you end up with this 50 picofarad. If you go parallel, you end up with double the picofarads at the same voltage rating. So by doing this, I've got 50 picofarads at double the voltage rating of whatever these capacitors are. So when I tried to measure these capacitors with my multimeter, they didn't measure anything. So I don't know if I'm doing that wrong or what, but I do have some more 100 picofarad capacitors on the way that aren't quite this small. But that's the idea, is I would be able to use this switch to switch between 0 capacitance, 100 picofarads, and then all the way at the bottom would be 50 picofarads. So it gives me a way to dial the capacitance. Just looking online, I saw where people had cut, so if you've got this, a lot of people would try to tune it and it wouldn't work, and then they would cut the capacitor. So this didn't work at all. It just didn't work well at all. But that came out of a power supply. I am going to still test it by cutting that capacitor, because I read a lot of things online where people said that they cut the capacitor and all of a sudden it worked. So I'm going to try it. It don't hurt anything, because this was basically junk anyway. But I'm not sure how well this is going to work. But what I have found is a 49-to-1, which would be this one. So if I were going to make a 49-to-1, actually this one. So this would be my 49-to-1. 49-to-1 gives you essentially they work higher. So if your antenna is, if this is your ground level and this is your quarter wavelength or half wavelength or whatever, a 49-to-1 would be better at a higher level. And then as you drop closer to the ground, you want to go to a 56-to-1, a 64-to-1, and so on and so forth, because as your antenna, so let's just say your ground level is this area here, and this is my antenna. As my antenna drops closer to the ground, I get a higher inductance reading on this antenna. So if I'm taking my antenna and I put it way up here, on an in-fed half wave, I'll have something like 2450 ohms. And then this, or this, 49-to-1 wrap is going to give me essentially 2450 ohms from the antenna, comes back in, and then goes to my center pin at 50 ohms. So that it essentially transforms 2450 ohms here back to the antenna. I always get these mixed up on which one goes where. I think this one goes to the antenna and that one's shield. But if that's the case, that goes back to my antenna, and it will be 50 ohms or thereabouts, translated from 2450 ohms here. So what I want to try is, if my antenna is up here, a 49-to-1 works well. But as I drop further, maybe a 56-to-1 works better there. Maybe down here a 64-to-1 works better. And maybe as you keep going, you have more inductance that you're translating. So it goes from, say, 2450 down to 3000, down to, whatever that reading is. So as you go down, you are going to be translating from 50 ohms all the way to, say, 4,000 ohms or whatever that may be. So what I want to do is, and I'd considered doing this where I had different cores. So like you start with a 49 to 1, and then you've got a 56 to 1, and then you got a 64 to 1, and then you've got a whatever it is after that, and then you just can connect to different antenna spots just to test it. But then I thought, at least my understanding of the way a transformer actually works is you can tap the transformer in a different place. So say this was, well, actually, I don't have to. You've got this transformer, and at 14, I come to the back side and I tap it, and I come over to this first position on my switch. 15 is my second position. 16 is the third. 17 is here. 18 and 19. So I can go all the way from a 49 to 1 all the way to a 19 to 1. And I hadn't done the math yet. I've got to figure up what the difference is, and I may not even need to go all the way over to that position. I also don't know how this switch will interfere, and I also don't know if I'm going to pick up any capacitance or inductance from here. So all of these wires are fairly close together. I've tried to space them apart as much as I could, and I've tried to, separate everything out as away from everything as much as I could. But, this is the best that I've got right now, and I figure it's worth trying. Worst case scenario, I just clip all the wires off and I use this for a single wound transformer. But all I've got invested at this point is a little bit of time and a little bit of trial and error. Once my capacitors come in, I'll use this switch to wire those into it. But what this gives me is a variable transformer that I can just switch on the fly. And the way I've kind of understood your transformer is it's an electrical gearbox. So just like your, say, a 5-speed transmission, you are sacrificing speed for torque. So your first gear, you're not going to be able to go very fast at all, but you've got a lot of torque at that speed. So if you were to reverse that and go the other direction, you've got a lot of speed with very little torque. So you go all the way to 5th gear, and you've got a ton of speed with very little torque. So the way I understand it is when you have a center-fed dipole, so you've got a, your center-fed part is there, and I'm not sure that I've got another piece of a wire somewhere. Okay, I don't. We're going to pretend that's the other side of my center-fed dipole. So if this is your center-fed dipole, so you've got one half of your thing here, and then the other half goes here, you're going to feed it at the center and come down to your radio. You've got, at that point, 50 ohms from here to here. So just to kind of wrap my brain around it, I'm looking at that like the easiest point to drive the antenna. So in the center of it is the easiest point, requires the least amount of torque. So I can essentially put high voltage, low amperage, or lots of speed, little torque. But if my antenna is an end fed, so I have done away with this and I'm feeding it at the end, and this is my half dipole length, instead of feeding it in the center, I'm feeding it over here. It requires more torque to run this antenna from the end, but not as much speed. So what I'm doing with my unun or whatever is I'm using it like a 5-speed transmission. Over here in the center, I can drive it in 5th gear because I don't require a lot of torque. But over here, I can drive it in 1st gear with my antenna. So I can go to 1st gear, I'm putting a lot of torque, so tons of amperage, but very little voltage. And I could have those two reversed. I don't remember what it is, but usually with an antenna, if this is your half-wave antenna, you are going to have higher voltages towards the end and lower amps, and lower voltage in the middle, higher amps in the middle, lower volts on the ends, if I'm not mistaken. Could be wrong about that. So I might have everything I'm saying might be backwards. It might be that I'm putting in a lot of volts here and very little amps to do the same thing with this. So this would be my gear shifter. I'm going from 5th gear, 4th gear, 3rd gear, 2nd gear, 1st gear, and granny low, or whatever. So as I drop my antenna lower, so maybe I'm 3 feet off the ground, maybe I can go into granny low, drive it at the 19th turn, and I've given myself more torque in granny low. I know that's a weird way to think about it, but that seems to make the most sense in my head. What this is, the idea of this little box, and I've 3D printed another one. So I didn't really like how deep this one is, so you can see how deep that is. This one's a little bit smaller, and so it would be like this. Your switch would be here, your antenna here, and then another switch here for the capacitor. So I've sort of jammed all those together. I did move the antenna further over from where it was. I probably should have moved the switch over a little bit. I could have, actually. But everything else is essentially the same. I've got the 2 mounting holes in the top. I'm going to make a 3D print something. 2/4 inch bolts will screw up into it, and then you'll have like a loop that it will hang from up there. And then over here is your switch. And what I'd considered doing is making a dipole out of this as well. So your center pin goes here, and then your ground could come over here. So I'd considered coming off of here to the center pin. One of these go to the transformer, and one of them goes to a secondary connector that bypasses this one. So it would go up here. So one side of your dipole would go this way, one side of your dipole would go this way, and it would totally eliminate this whole mechanism. So with one thing, I could use it to make end feds, I could use it to make a dipole, I could do a lot of stuff with one box. But I really don't, I'm really focusing on end feds at this point. And so I'll use this for capacitance testing. My understanding, and again I could be wrong, is at certain, so you've got 2 different ends of the spectrum. You've got your 80 meter all the way down to your 10 meter. I think at 10 meter you require less capacitance to balance everything, and at say 80 meter you require more. So I think it was, from what I could tell, you want about 200 picofarads for your 80 meter and up, and you want about 50 for your 10 meter and down. And usually people go with 100 picofarads, which is basically right in the middle. So it's going to be okay for one and okay for the other, but it won't be great for any of them except for say your 20 meter band. Maybe 100 picofarads would be perfect. Right now I'm going to switch between 0, 50, and 100 picofarads. So that'll give me the ability to kind of tune. And if I wanted to, and I might still do this, I could add, so my one option, if I go here, I'm going from here through here to the center pin. And if I could do that, I could add one in parallel here, and that would actually be 200 picofarads. And I don't know the math, I'd have to look at it again, but if you flipped over that way and you had this one in parallel and that one in serial, so if you had 200 picofarads here and 100 here, you would end up with like what, 75 picofarads or something. So I might be able to, just by adding one here, I could have, and again, I'm just spitballing right now, but if you've got your parallel setting here with 200 picofarads, and then this one at 100 picofarads, and then you serial 100 to 200 picofarads, you would be somewhere between the two. You wouldn't be 50, you'd be between 50 and 100. So just say that's 75 picofarads on the low end. If I switch to one end, 0 picofarads, and then 200 on the high end, that would give me the ability to kind of stay in the other range. So I'm going to test that at some point and see what my actual values are. But my understanding is, so I generally don't use 10 meter. I generally stay 40 meter and up. Sometimes I go to 20, sometimes I go down to 15. But what I'm looking for an end fed is I want to go from 80 meter to 40 meter. Those are the two main ones that I'm focused on. That is why I bought these. This is a Type 31, whatever you call it, ferrite core. That Type 31 is good for 1 to 10 megahertz. So that's going to cover your 160, your 80, and your 40 megahertz, and it is the most efficient at those frequencies. So this won't do me any good at, say, 20 megahertz. It won't do me any good at 10 megahertz. Or, no, I'm sorry, not 10 megahertz, 20 meter or 10 meter. But for 40 and 80, it's far more efficient than your Type 43 that is good, I think, for 3 to 30 megahertz. I could be wrong, but it's, you know, it's not, it is more efficient for, say, 20 meter. This would be a good, okay at 40 meter, really good at 20, decent at 10, where this one is going to be really good at 40 and 80 megahertz. So I'm wanting to try one with 2 of them stacked together and one with 1. So I'll build like a small, where'd it go? Little enclosure thing that I 3D printed, but I don't see it. Yeah, I've lost it. So I'm going to mess with some of these. Some of these are different windings, so I'm staying away. I think one of these, which, I'm sorry, I'm terribly not organized. That's going to be your 49 to 1, and then I've got a 56 to 1 and a 64 to 1. So I'm going to try different windings just by themselves. And if you're wondering, this is not your typical, so you've got, what I see most people do is this. You're winding half here and half here. So you've got your 2 primaries, and it's actually 2 wires twisted together, and then your secondaries start here at the halfway point, come across, and then finish. You see how much further apart those are spaced versus this. This is what you would call an auto transformer. I have 1 wire that's wrapped around, and then I've tapped into my second winding. So coming up after my second wind, and the way they count that is your, I've got that stuff in there, your first turn. So you're going to see this, your first turn is the inside. So that is my first turn, coming around, second turn, coming around, and then I may have done that wrong. Either way, I'll figure it out. But that's how you would do it. Now, one thing that I found is if the first ones I did, if you look at where the enamel is, you can see the difference there. So if you look now, you can see where the enamel stops, about where my finger stops, and then you've got bare wire. What I found that works really well for that, because I was using just a pocket knife, I was just taking and scraping, and it works, but it's really annoying. But this works really well. Just a stainless steel wire brush. I'll take it and take the wire and it just eats the enamel right off and gets you to a nice bare wire. And you can do it so, you know, when I was doing these, I could just kind of hit that with that stainless steel wire and bare it off, and then solder right to it. Resin actually helps quite a bit with that. It kind of helps it stick. And then what I've done is I'm using this. When I say resin, that's a different resin. This is UV resin that uses little UV light to cure it. So I'll kind of put it on there, and that's why it's clear like that. And I like that. It hardens well. And then what this is just hot glue. So that's what I've got on that one. I'm just trying different things. But if this works, then it would be a very, it would be a more versatile, albeit I'm sure I'm going to get some losses through here somehow. But what I'm figuring is I'm going to hook this up to my G90 with its SWR sweep, and then I'm going to test switching to different, you know, quote-unquote gears on this thing. I'm going to see why if I go from 49 to 1, which is my first option on my switch. So that's going to be your 49, your 56 to 1, your 64 to 1. And I've not done the math for the rest, so I've got 3 more options after that. So I'm going to see, you know, it might even be that I can lay the stinking thing right on the ground, or maybe I can get 3 feet off the ground and have a good invis antenna by being able to tune this. So it's basically a tunable in-fed half wave in kind of a small box, which that's actually not very small. That's what that one's going to end up being, is a little bit smaller, and I'll probably end up dropping it a little bit more and try to get it as small as I possibly can. So what I've also done here is the original box, I was going to have a plate or maybe a circuit board that would bolt in here. But I didn't really like that. And once I got it in here, I figured out that these little tabs that I put on the inside, I can run my zip tie around, and it holds really well. Now these are all made out of PLA, but you know, I'm sure they're not going to withstand the temperature or any of that, but I'm just going to be using these for testing. And if it works, I'll fine-tune it and probably print this in something like ASA. But anyway, if anybody has any suggestions, or if you think that I could do this better somehow or whatever, I am going to make a lid for this out of, I'm going to laser cut some acrylic that'll just bolt on so you can still see in there and everything. Either that, or I'll 3D print a lid with a glued in acrylic window that will bolt onto this, so you'll be able to see inside of it. You're also going to have the top part here, and I think what I'm going to do is come out of the top part with a loop right in here. So essentially your wire connects here and then comes up to a strain relief and then goes out. So you'll be able to use that as an antenna. But either way, if anybody has any suggestions, or if you think I'm barking up the wrong tree, let me know. But I'll eventually do some testing and I'll let you know. I've also done, let's see, I've got a nano VNA that I made these with. So I took some resistors and put them together, and essentially your 2450 ohms, these are multiples put together, so the resistors would show. I should be able to do this with 2 resistors, but when I did, it didn't add up to the 2450, so I just kept adding resistors until I actually got a real measurement of 2450. These are some kind of cheap resistors. And then you've got your 2800, and then you've got your 3033 kilo ohm. So what this is this is your 49 to 1 ohm thing that you would see. This is your 56 to 1, and this is your 64 to 1. And that there's a way to test your efficiency on your antenna using those resistors and a nano VNA. I'm still trying to sort all of that out, but eventually I'm going to do that and test the efficiency on different cores. I want to see how all of these work. So if everything that I've read is right, this type 31 will actually, as small as it is, be more efficient on 40 and 80 than this great big one of those, because it's built for that frequency. It's actually going to do better. And I generally tend to focus on 40 and 80, sometimes 20. So, the cool part is I might even be able to use one of these. It's small enough that you might even be able to put it in some kind of a package where you've got your 40 and under here, your 40 and up here, so you could switch between them if you wanted to somehow. I don't know if that's what I'll do, but I might. So anyway, if anybody has any suggestions or anything like that, please let me know. One thing I am kind of disappointed in is I've joined a ham radio club here in my county, and you would think there'd be more interest in this kind of thing. You would think you'd find an older Elmer, so to speak, that you could do some of this stuff with, but what I'm finding is I'm getting far more traction with ChatGPT and books that I find on the internet than any of the people that I've talked to in that club. I'm hoping that may change, but in all reality, it's looking like, unfortunately, we've lost that touch where older people help younger people. I'd love to hook up with somebody that's actually been doing this for a lot longer than I have, that I can hopefully experiment with. So if you're out there and you're interested in some of this stuff and you're close to my area, man, I'd love to get together with you. So give me a call and let me know, and leave a message or whatever. We'll figure it out. So I'll let you know where all of this stands at some point when I figure it all out myself. But I just figured that's something that I've not really seen anybody really try this. I've seen little posts here and there after I started messing with it where somebody's done something similar. They didn't use a switch. They just had different studs for different wraps, and according to them, it worked really well. I want something that I can just go, hey, I want to tune, and hey, that works the best right there. I can get my antenna up so far, and I can fiddle with this until I get the perfect SWR or close to it, and then I am dead on the money. So this might be a way to sort of tune your antenna just by selecting whichever wrap it's coming off of. So anyway, I'm all about versatility. I'm all about how can I make something work where I've got this one antenna. I don't want to have to carry a box of antennas. So if I can have something similar to this, then that makes the most sense to me. So you guys have a good day. Hope that made sense. Bye.